video, we are going to go over finding particular equations given multiple different types of tables. So as we look through these tables, one thing that we want to keep in mind are the different patterns that can happen in tables. So let's first just kind of make ourselves a table of contents over here of the different patterns that could possibly happen. One pattern that could happen is an add pattern. And what an add pattern is as you increase your x values, it's adding at a constant rate, and your f of x or your y values are also going up at a constant rate. That would indicate that we have a linear function. I'm just going to put an L there. No, I can write out linear. There's enough room. That would indicate that this table is a linear function. The next type of pattern that we might see would be add multiply. An add multiply pattern would be that as you add on this side by a constant rate, you multiply on this side by a constant ratio. If that's the case, then we'd be looking at an exponential equation. Another type of pattern we might see would be multiply. And what that would look like is as these are multiplying by a constant ratio, these are also multiplying by a constant ratio. Sometimes when we're looking at a multiply pattern, you will have to omit certain ordered pairs or certain rows in the table that don't help you. If this is the case, this is a power function. The last type of pattern that we'll be looking at in this video is a second difference pattern. What a second difference pattern looks like is as we are adding by a constant rate here, these are not adding by a constant rate, but they are the second time you add them. If that's the case, this will be a quadratic function. So, let's try to analyze this one and figure out what pattern we have going on. Well, it does not look like it's a multiply pattern over here, because 1 times 3 gets us to 3, but 3 times 3 is 9, and we don't have a 9. So we're going to say that this has to be some sort of add pattern. So 1 to 3 is plus 2, 3 to 5 is plus 2, and 5 to 7 is plus 2. That is adding by a constant rate. Now let's look at the other side. -5 to -1, well, if this was a multiply pattern, we'd be multiplying 5 by 1/5. 1 times 1/5 does not get us to 3. So let's look for an add pattern. -5 plus 4 gets us to -1. Plus 4 gets us to 3. Plus 4 gets us to 7. So it looks like we're going up by a constant rate of 4. This is an add pattern. It's adding by a constant rate on this side, it's adding by a constant rate on this side, and because it's an add pattern, this is a linear function. So we've identified what type of function it is. Now we want to write our particular equation. So to write our particular equation, the first thing we need to realize, or remember I guess, is what's the general equation for a linear function? The general equation is ax plus b equals y. Sometimes you say this mx plus b. In this case, we're just going to say ax plus b. Now to figure out what a and b are, we can use some of our ordered pairs from this table. Now you'll remember that a is your slope, which is rise over run, and b is your y-intercept. So we could set up a system of equations, or we could intuitively think, well, 4 divided by 2 is 2, so my slope has to be 2, right? So rise over run, this is my rise, this is my run. 4 divided by 2 is 2. And then if I subtract 2 from here to get to my y-intercept, it'd be -7. So you could intuitively think of this. I'm going to show you by setting up a system. Now, as I set up my system, one thing we want to keep in mind is that all of these are our x values, which means I can plug them in here. All of these are our y values, which means I can plug them in here. So let's just take our first ordered pair and write our general equation. A times x, which is 1, plus b equals -5, because that's y. There's one equation. Well, we have two unknowns. And because we have two unknowns, we have to write two equations. So let's just use the second ordered pair. And that's going to look like a times 3, because 3 is x, plus b equals -1. Now we have many different ways of solving this. We could do elimination, we could do substitution, we could graph it, we could even set up a matrix and solve it using a matrix. This particular system is set up very nicely for elimination. So let's just rewrite it. A times 1 is just a, plus b equals -5. A times 3 is 3a, plus b equals -1. This is set up nicely for elimination because the a's are lined up and the b's are lined up. So to eliminate, let's just subtract our second equation from our first one. So you're going to take this whole equation and subtract. A minus 3a is -2a. B minus b eliminates 0. -5 minus -1. Well, we have a double negative here, so really we add that 1. So -5 plus 1 is -4. Get a by itself by dividing by -2. And we get that a equals 2. Well, that's what we said earlier as well, because we were looking at this and rise over run, 4 divided by 2 was 2. So we know that we're on the right track. We're going to take this, you can't really see this marker very well, but we're going to plug it in right there. Now, let's solve for b. Well, how can we do that? We will take this a value and plug it into either equation. Doesn't matter which one. I'm just going to plug it into the first one. 2 plus b equals -5. How do I get b by itself? I subtract 2. b equals -7. Again, when we were talking about this intuitively, that's the same thing we said. We said our slope was 2, and if I subtract 2 from -5 to get back up to my 0, it'd be -7. So we will take this value and plug it in for b. So our particular equation for this table is y equals 2x minus 7. We love double checking our work. We love making sure that we are correct. So go ahead and take out your graphing calculator. Click on y equals and enter this, 2x minus 7. Now if you hit second, that enables all of the blue words on top of the buttons. Well, we want to go into our table. So I'm going to hit second, graph, because that brings you into the table. And I'm just going to make sure that the ordered pairs are the same. So I'm going to go down to 1, 1, negative 5. Perfect. Go down to 3, 3, negative 1. Perfect. 5, 3. Perfect. 7, 7. Perfect. So we know that we have found the correct equation. We have a new table now. So again, we need to analyze what pattern is happening. We need to look and see if it's going to be add, add, multiply, 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 or second difference. So as I look on this side, 2 times 2 gets me to 4. 4 times 2, there is an 8 here. So it might be a multiply, multiply pattern. Let's check on this side. Well, to figure out what times what is going to get us there, we'll do 26 divided by 8. So that's 3.25. So if I multiply 26 by 3.25 and I get 110, then this is a multiply, multiply pattern. No, I did not get that. So this cannot be a multiply, multiply. So we know multiply, multiply is out. We know add, add is out just because if we look, 26 minus 8 is 18, 60 minus 26 is 34, so it can't be add, add. Can't be add, multiply, we just figured that out. So that means that maybe it's a second difference. So second difference, from here to here, we just checked, and that's an add 18. From here to here, that's an add 34. And from here to here, 110 minus 60 is an add 50. If it was a second difference pattern, that means that now between here and here and here would be the same thing. So 34 minus 18, that's add 16. 50 minus 34, that's add 16. That's our second difference, and we have a constant second difference, and so that means this is going to be quadratic. So, we know that it's quadratic because we found the pattern. Now, how do we solve for quadratic? Well, let's start by writing the general equation down. The general equation for a quadratic is a times x squared plus b times x plus c equals y. Well, we have a lot of x's and y's. We have 4 sets of them. But we don't know what a, b, and c are. So to solve for a, b, and c, let's set up a system of equations. What we need to know, or what we need to have though, is 3, because we have 3 unknowns. So let's see if we can write 3 different equations. Let's take our first ordered pair, and we'd have a times 2 squared plus B times 2 plus C equals 8. What I did there was I took 2 and I plugged it in for all of my x's. Then I took 8 and I plugged it in for y. Now I can simplify that a little bit. 2 squared is 4, and then that would be 2b plus c equals 8. There's one equation. I need 3 of them. So let's take the second ordered pair and write another one. A times 4 squared plus b times 4 plus c equals 26. We can simplify it. 4 squared is 16, so we have 16a plus 4b plus c equals 26. That's our second equation. I need 3. I have 3 unknowns. I need 3 equations. So let's just go to the third ordered pair. A times 6 squared plus b times 6 plus c equals 60. Let's simplify it. 6 squared is 36. So I have 36a plus 6b plus c equals 60. There's our third equation. Let's write it a little bit nicer, and I'll write it off to the side just so that we have those 3 next to each other. 4a plus 2b plus c equals 8. 16a plus 4b plus c equals 26. 36a plus 6b plus c equals 60. This is a 6b, sorry. So, we have a system of 3 equations. We could start solving it by hand. We could get c alone and substitute it in, but that's so much work. As I look through these, all of these highest degree is 1, and so because the highest degree for each term is 1, I could just set up a matrix. So if I wrote a matrix for this first one, it would be 4, 2, 1, 8. Because 4 is the coefficient of A, 2 is the coefficient of B, and 1 is the coefficient of C, 8 is the answer. So let's do the next one. 16, 4, 1, 26. Again, 16 is the coefficient of A, 4 is the coefficient of B, 1 is the coefficient of C, 26 is the answer. And then the last one, 36, 6, 1, 60. And now I can use matrix operations to solve this. So go ahead and grab your graphing calculator. Okay. If you don't have a graphing calculator at home, there is an app on your phone that you can get. I don't know if it's just for Android phones, but I have an Android phone, and it's called WabbitMu. So WabbitMu. And if you click on that, it looks just like a graphing calculator. And it has all the same capabilities, and so you could go into that matrix and create a matrix in there. And it does all the same solving and everything. So if you don't have a graphing calculator at home, you could get that app on your phone. Again, I don't know if you can get it for Apple. I have an Android phone. So yeah. So, graphing calculator. Go into your matrix screen. If you hit the second button, it enables all of the blue text on top of these buttons. Matrix is the 4th button down, so hit second and then matrix. There are different options up on top. There's names. That's if you already have a matrix in there. Math, this is what it does with our matrix. And then edit. Edit is how you're going to actually input a new matrix. So go to edit, hit enter to bring you into there. And then you have to tell the matrix which size. You do number of rows first, and then number of columns. So we have 3 rows, and then we have 4 columns. So 3 by 4. Enter each of these numbers in, and double check yourself, because if you enter something wrong, it's not going to get you the right answer in the end. So put the number, and then you hit enter. 4, 2, 1, 8. I have to hit enter each time to say I'm done with that cell. 16, 4, 1, 26, 36, 6, 1, 60. So I've entered it into the matrix. Now I'm going to quit out of this screen. So if you hit second and then this mode button, it says quit right above it, so it'll quit. Now I need to do some math on this matrix. In particular, the math I'm going to do is a row reduction. A row reduction makes it go 1, 1, 1, and everything else zeros. So that's going to tell us that when we have 1A, 0 B's, 0 C's, what does it equal? And so forth. So go back to that matrix screen, second matrix. Now we're going to do math, so scroll over to math and go all the way down until you see RREF. That is a row reduction epsilon form. Hit enter. Go back into the matrix one more time, second matrix, and now we're going to pull in A. A before didn't say 3 by 4, and now it does because we actually have a matrix in there. So I'm going to hit enter there, enter, and here are the solutions. So it says when there's 1A, 0 B's, and 0 C's, it equals 2. When there's 0 A's, 1 B, 0 C's, it equals -3. When there's 0 A's, 0 B's, 1 C, it equals 6. So essentially, that's telling you what A, B, and C are. A is 2, B is -3, C is 6. Now we're ready to write our equation. We take this, plug it in here. We take this, plug it in here, and this, and plug it in there. And so our particular equation is 2x squared. Oh, that should be a minus. Minus, because it's -3, minus 3x plus 6 equals y. We love double checking our answer. So let's go into y equals and put our new equation in. 2x squared minus 3x plus 6. And let's make sure we get this in our table. 2, 8. Perfect. 426. Perfect. 6, 6. We have a new table again. And so we need to figure out, is this going to be an add, multiply, 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 or second difference pattern? So as we look at the x side, it could be an adding pattern because it goes from 2 to 4 to 6 to 8. It could also be a multiplying pattern because we have 2, 4, and 8. So we want to analyze what's happening on this side. I'm going to see if I do -486 divided by 54, I get -9. Well, now let's take this number and divide it by that one and see what we get. -4,374 divided by -486. We get 9. This one should have been a 9 as well. Then let's just try it one more time. -39,366 divided by -4,374. We get 9 again. So it looks like what this is an add multiply pattern. Because each time we go up a row, it's multiplying by 9. And if it's a add multiply pattern, it's exponential. So because it's an add multiply pattern, it's exponential. The general equation for an exponential is y equals a times b to the x. We don't know what a and b are, but we have several x and y values that can work. And so let's set up a system of equations. We have negative 54 equals a times b to the power of 2. That negative 54 came from here, because that's what y equals. And the 2 came from here, because that's what x equals. Let's make one more. Negative 486 equals a times b to the power of 4. Negative 486 came from here, 4 came from there. Now these aren't linear, so we aren't just going to add and subtract them to get things to cancel out. Rather, let's take the second one and divide it by the first one. You could do it the other way as well, but the numbers here are bigger, and so it's just going to be a little bit cleaner if we take this one and divide it by that one. Well, we already figured out that negative 486 divided by negative 54 is 9. We did that right here. A divided by A is 1, so we don't have to write that down. B to the fourth divided by B to the second. Well, our exponent properties say if you divide an exponent by another, you subtract them. So this becomes B squared. How do we get B by itself? Oh, take the square root of both sides. The square root of 9 is 3, and so B equals 3. B equals 3. And so this is going to replace that B right there. How do we figure out A? Well, let's take the 3 and plug it into our first equation. Negative 54 equals A times 3 to the second power. I just took that 3 and plugged it in for B because now we know that's what B is. Well, 3 squared is 9, so we have negative 54 equals A times 9. To get A by itself, divide by 9. Negative 54 divided by 9 is negative 6. So A equals negative 6. Take this and plug it in for A. So our particular equation for this table is y equals negative 6 times 3 to the power of x. You can't multiply these into each other. PEMDAS would say that we have to do exponents first, then multiplication. So keep these separate. Our base is 3, our y-intercept is negative 6. We love double checking our work, so let's take our calculator, go into y equals negative 6 times 3 to the power of x. Let's go to our table, 254, 4, 486, 6, negative 4,374, 8, negative 39,366. Awesome. We did it. And here is our last table of the day. So again, we're going to look, does it have an add pattern, add, multiply, 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 or second difference? So over here, if I look down this side, it could be an adding pattern because 1 plus 1 is 2, 2 plus 1 is 3, and 3 plus 1 is 4. But it definitely doesn't look like it's an adding pattern here. It could be an add multiply pattern. So let's check that out. 4 divided by 0.25 gives us 16. 20.25 divided by 4 does not give us 16. And so what that tells me is it's probably going to be a multiply pattern over here. And if that's the case, then 1 times 2 gets us 2. 2 times 2 doesn't get us 3, so we have to skip 3. 2 times 2 gives us 4, and we are going to skip here. Let's see if that works on this side. We already know that 4 divided by 0.25 is a times 16. So if we're going to skip the third one, let's do 64 divided by 4, and we already know that is 16. So this is a multiply, multiply pattern. So when you're looking at multiply, multiply patterns, sometimes you will have to skip one of the rows, and that's okay. So because this is a multiply, multiply pattern, it's going to be a power function. Our general equation for a power function is a times x to the b equals y. So, in order to solve this, we have a and b as unknowns. We have a bunch of x's and y's from this table. We need to set up a system using 2. So, let's use our first one. A times 1 to the power of b equals 0.25. And then we have a times 2 to the power of b equals 4. I just got those using my x's here. I replaced x with those, and I replaced y with these. And so just to make it a little bit easier to see, I'll highlight my x's. That's where all those numbers came from. And then this is where my y's came from. Now, I need to try to figure out what a and b are. Let's divide our second equation by our first equation. A divided by a is 1. Now, these have the same exponent, and so that means that that would be like the same thing as 2 over 1 to the power of b equals 4 over 0.25. But 2 over 1 is just 2, so we have 2 to the power of b equals 4 divided by 0.25 was 16. We have b in our exponent. How do we get b out of the exponent? What is the inverse operation to exponentials? Oh, log. So if I log both sides, because what you do to one side you must do to the other, if I log both sides, then I can use my really, really, really cool log and exponent rule, where this b actually is just now multiplied here. So what that looks like is b times the log of 2 equals the log of 16. How do I get b by itself? B times the log of 2 equals log of 16. I could just divide both sides by log of 2. B equals log 16 divided by log of 2. We could do that in our calculator. The log button is right here. It's 1, 2, 3, 4 up from the bottom. Log 16, close your parenthesis, divided by log of 2, close your parenthesis, and we get that b equals 4. So b equals 4, I now know that is what's in the exponent. How do I find a? We'll take our b value and plug it into one of the equations. Let's just plug it into the first equation. A times 1 to the power of 4 equals 0.25. Well, 1 to the power of 4 is just 1. A times 1 is just A. A equals 0.25. That's our A value. We now have all the information that we need to write our equation. Our equation is y equals a, which is 0.25, times x to the power of b, which is 4. We love checking our work. Checking our work is the greatest thing ever. So we're going to go to our y equals. We're going to put 0.25x. That wasn't an x. 0.25x. Oh my goodness. My fingers are broken. X to the power of 4. Go into our table. 1 is 0.25. 2 is 4. 3 is 20.25. 4 is 64. So there we have it. Finding particular equation.